silence. Then, a roar. It's the sound of progress, of innovation, the very essence of modern flight. But sometimes, in the pursuit of speed, of market dominance, something goes catastrophically wrong. What if the very machines designed to lift us to the sky held a secret? A hidden truth beneath layers of code and steel. A flaw. Not just any flaw, but a fatal one. This is the story of Boeing's 737 MAX. A plane designed to fly us into the future, but which instead brought the world to a halt. A story of ambition, compromise, and an unraveling mystery. We're counting down the critical moments, the decisions that led to a crisis. Coming in at number 5 on our list of critical factors, the pressure cooker. Imagine a global race. Two titans of aerospace locked in an endless battle for the skies. For decades, Boeing reigned supreme, unchallenged. But a new rival emerged. With a new, fuel-efficient jet that threatened to steal market share. The pressure mounted. Intense. Unyielding. Boeing needed an answer. Fast. An answer that didn't just compete, but truly dominated. But at what cost? What corners might be cut in the relentless pursuit of speed to market? The response was the 737 MAX. Not an entirely new plane, but an evolution. A modification of a legendary design. Why not start from scratch? Time. Money. The market wouldn't wait. Boeing executives faced a choice: innovate entirely, or adapt quickly. They chose adaptation. But this wasn't just a tweak. The new, larger, more fuel-efficient engines, pushed further forward and higher on the wing, fundamentally altered the aircraft's aerodynamics. A compromise was made. A necessary evil, perhaps, to keep the MAX competitive. But a compromise that would echo through history. What unseen forces were at play? This aerodynamic shift created a problem. During certain maneuvers, particularly at high angles of attack, the aircraft's nose tended to pitch up. A potentially dangerous characteristic. Boeing engineers needed a solution. A digital one. To make the MAX feel like its predecessors. To avoid costly, time-consuming retraining for pilots. This decision, seemingly innocuous, birthed a system. A computer program designed to gently nudge the nose down. An invisible hand, correcting for a physical reality. Few knew its full extent. Fewer still understood its potential for catastrophe. A subtle correction, with devastating implications. Number 4 on our list, the design compromise. The decision to modify the aging 737 airframe, rather than designing a brand new plane, was fraught with challenges. It meant working within existing structural limits. The engines, critical for fuel efficiency, had to be moved forward and higher on the wing. This placement, while offering aerodynamic benefits, introduced new flight characteristics. Characteristics that the previous 737 models didn't possess. A fundamental alteration. One that demanded a system to mask these changes from the pilots. A compromise, not just in design, but potentially in transparency. To counteract the MAX's tendency to pitch up, Boeing developed the Maneuvering Characteristics Augmentation System, or MCAS. This wasn't a supplemental safety system, it was fundamental to the aircraft's certification. Without it, the MAX wouldn't meet regulatory requirements. It was designed to push the plane's nose down automatically, preventing a stall. A seemingly benign, background system. But how much authority did it truly have? And what if its inputs were based on faulty information? The seeds of a disaster were sown, in the very code designed to ensure safety. Crucially, pilots were largely unaware of MCAS, or at best, had minimal training on it. It wasn't detailed in the flight manual. Boeing assumed it would operate in the background, unnoticed. They promised airlines that pilots wouldn't need extensive new training. A major selling point. Cost savings. But this secrecy, this lack of transparency, would prove fatal. When the system malfunctioned, pilots would face an adversary they didn't even know existed. A digital ghost in the machine. Operating autonomously. And powerfully. What happens when the human pilot is no longer fully in control? Now, at number 3, we zoom in on the specific component that would become infamous, the hidden hand of MCAS. The Maneuvering Characteristics Augmentation System. Its purpose, to automatically push the nose down if it detected a high angle of attack. But the system relied on just one angle of attack, AOA, sensor. One single point of failure. If that sensor provided faulty data, MCAS would activate erroneously. Repeatedly. Pushing the nose down, against the pilot's commands. A digital tug-of-war. What kind of engineering logic allows such a critical system to depend on a single, vulnerable input? The decision to use a single AOA sensor for MCAS input was a critical vulnerability. What if that sensor froze? Or sent corrupt data? The system would blindly execute its programmed commands, regardless of reality. A crucial safeguard, redundancy, was missing. Why? Cost? Complexity? A belief that such a failure was improbable? The consequences would be devastating. A machine, programmed for safety, becoming an engine of destruction due to a single, faulty signal. The very foundation of trust in automation, shattered. In emergency situations, pilots are trained to react. To troubleshoot. But MCAS was designed to be powerful. So powerful, in fact, that it could override manual controls. Repeatedly. Even when pilots pulled back on the yoke, the system could push the nose down again. And again. The sheer force of the trim motor made it incredibly difficult for pilots to physically counteract. Imagine battling an invisible force, within your own aircraft, with no clear understanding of its origin or how to disengage it. A terrifying scenario. Where does the line between automation and pilot authority truly lie? At number 2, the first warning. October 29, 2018. Lion Air Flight 610. A brand new Boeing 737 MAX 8. Just 2 months old. It departed Jakarta, Indonesia. On board, 189 souls. The flight lasted just 13 minutes. Before plunging into the Java Sea. Initial reports were chaotic. Conflicting. But soon, a pattern emerged. The aircraft experienced an uncontrolled dive. The flight data recorder, recovered from the depths, told a chilling story, repeated, automatic nose-down commands. The first tragic manifestation of the flaw. A warning signal, painted in the darkest hues. But was it heard? Investigators quickly focused on the AOA sensor. It had malfunctioned on the previous flight, and again on Flight 610. Sending erroneous data. Triggering MCAS. The pilots fought valiantly. Pulling the nose up. But the system pushed it down. Over and over. A terrifying struggle for control. Boeing knew. Or should have known. They had received reports. Previous incidents of erroneous AOA readings. But no immediate, sweeping action was taken. The problem, while identified, was not publicly acknowledged as a systemic, fatal flaw. The world watched, but did it truly see the depth of the issue? Following the Lion Air tragedy, Boeing issued an operations manual bulletin, essentially an advisory to airlines about how to handle an erroneous AOA sensor. But it didn't specifically mention MCAS. It implied the problem was a rare event, a pilot training issue. Not a fundamental design flaw. The FAA, too, issued an airworthiness directive, but it was limited. The implications were immense. Lives had been lost. Yet, the full scope of the vulnerability remained obscured. A crucial opportunity to prevent future tragedies, tragically missed. What else could have been done? Despite Boeing's minimized response, whispers grew louder. Aviation experts, pilots, families of the victims. They demanded answers. They saw similarities to previous Boeing incidents. Was this a pattern? A symptom of a deeper corporate culture? The pressure was building, a slow burn of public distrust. Yet, the 737 MAX continued to fly. Governments around the world, including the US, still deemed it safe. The stage was set for an even greater tragedy. One that would leave no room for doubt. The first warning had been given. But a second was waiting in the wings. A chilling echo. And now, the most critical factor, number 1, the second tragedy. March 10, 2019. Less than 5 months after Lion Air. Ethiopian Airlines Flight 302. Another Boeing 737 MAX 8. 6 minutes after takeoff from Addis Ababa, it too plunged to the earth, killing all 157 people on board. The world watched in horror. The parallels were undeniable. A chilling, horrific déjà vu. This wasn't an isolated incident. This was a pattern. The fatal flaw had struck again. The sheer weight of two identical disasters, within such a short time frame, was inescapable. What could possibly explain this terrifying repetition? The similarities between the two crashes were too stark to ignore. Both planes experienced erratic flight paths, similar nose-down commands. This time, governments acted swiftly. Unprecedented. China was first. Then Indonesia, Ethiopia, and many others. Country after country. Until finally, the US FAA, traditionally slow to act, grounded the entire global fleet of Boeing 737 MAX aircraft. The most profitable plane in Boeing's history, rendered useless. A symbol of technological prowess, now a monument to a tragic design oversight. The full extent of the problem was finally, unequivocally, laid bare. But at what cost? The investigations into both crashes confirmed it. MCAS, relying on a single, faulty AOA sensor, repeatedly forced the aircraft's nose down. The pilots, despite their training and desperate efforts, could not overcome the system's powerful, erroneous inputs. The fatal flaw wasn't just a technical glitch, it was a cascade of decisions. Pressures to compete. Design compromises. Lack of transparency. Inadequate pilot training. Regulatory oversight that failed. A system-wide breakdown that transformed a design fix into a deadly trap. The trust in a century-old aviation giant shattered. The fallout was immense. Boeing faced billions in fines, compensation, and legal battles. Its reputation tarnished. Executives resigned. The FAA underwent intense scrutiny for its certification process. But the greatest cost, of course, was human. 346 lives, needlessly lost. The 737 MAX eventually returned to service, but only after extensive software updates, redesigns, and new pilot training. The story of the Boeing 737 MAX serves as a stark reminder. A powerful cautionary tale. What lessons have truly been learned? And what safeguards are now in place to ensure such a fatal flaw never takes flight again?